the rest of your software is kind of stopped. And the way PHP gets around this, because you might actually have more than one visitor to your website, is by running multiple PHP processes. But in JavaScript land, the way we usually solve this is by the functional programming concept of continuation passing style. So you call a function, and instead of waiting for the function to complete, what you do is you give it another function as an argument saying, hey, call this function when you're done. And then the rest of your software can be doing something else. The downside, of course, is this is how my first Node.js program looked like. You get to this callback Christmas tree. Of course, now we have promises and stuff, but this is still how a lot of asynchronous JavaScript code looks like. And sometimes it would be nice to have a map. I mean, we humans have very good spatial understanding. We've spent thousands of years throwing rocks at animals on the savannah. And yeah, with something like this, it's a lot easier to figure out what's connected to what. If something happens here, then it trickles down that line, right? And that's kind of where I come into the picture. So, like 5 years ago, 6 years ago, I was doing some projects in the US, and that involved commuting up and down the west coast between Oregon and San Francisco. And yeah, nice scenery, also long empty roads where I had a lot of time to think. I was kind of transitioning from the world of PHP to JavaScript land, and I was very frustrated about the tooling. And I was reading a lot of papers at the road motels at night, and there was one that really got my attention, and that was the concept of flow-based programming by this gentleman here, Paul Morrison. The book is reasonably recent. He wrote it when he retired, but the original papers and concepts of flow-based programming are from late 1960s. So what we're talking about here is like really cutting-edge programming concepts. And to understand the basic, like where flow-based programming comes from, you have to consider how software was done in that time. So we're still talking about the punch card era, unit record machines at IBM. And the way programming worked there was you had these big machines that take punch cards, and they would do something. They would basically run some algorithm on a set of data. Sometimes you could configure them by putting configuration punch cards in one slot and data punch cards in another slot. But they would just do one thing. So you would have these machines that do one thing to your data. And then to make bigger programs, you would have these flow charts that tell your ops people that when there are cards in this slot, you take them and you carry them to that slot of that next machine. And then these people in white jackets would do this thing between your big computers. And basically flow-based programming is just this, except now we don't have to carry our data packets from one algorithm to another by hand. We can have a computer do it. Paul Morrison, of course, wasn't the only one who came up with ideas like this. Here's Alan Kay, inventor of object-oriented programming. His idea was very similar, having things that communicate with each other by messages. Very kind of biological, very natural concept, but then, I don't know, somehow we got Java. And if you've done any Unix or Linux, these ideas might also sound familiar. The Unix philosophy, writing little programs that do one thing, and then that can be connected with each other. One could argue actually that the Unix shell or Linux shell is a flow-based programming environment, but usually in 1D. So you can pipe the output of one program as to be the input of a second program. You can theoretically do some splits and joins, but it's usually so tedious that people don't do it. And so what NoFlo is basically flow-based programming in 2D. So you have this two-dimensional canvas and you can connect your piece of your program together.
So, I mean, we're going to do some questions and answers later and at the round table, but I'm going to spare you one that you would probably ask. That's, hasn't this been tried before? And yes, of course, there's been a lot of ideas all the way from Grails in the 60s to the modern era to do this boxes and arrows kind of flowchart programming. And one could argue that they haven't reached mass adoption. Like, we're still using these clunky text editors to write our software. But there are certain areas, visual effects industry, a lot of engineering simulation work is being done with tools like NoFlo. And what we're trying to do here by bringing it to JavaScript is to make it possible to write general purpose software, whether it's front end, back end, mobile, with these ideas. So yeah, that's basically NoFlo. So what NoFlo is an open source project that gives you the necessary tools and kind of support libraries to do flow-based programs in JavaScript. And yeah, there's two parts of NoFlo. So one is the components, so the actual boxes that contain some sort of an algorithm, and then there's the graphs that where you define how you connect boxes. So we can start. There's not going to be much code in this talk, but a little bit. So here's just to show you how you write a NoFlo component in JavaScript. To kind of split that in areas, what we have is, yeah, of course you need to load the NoFlo library, and then you instantiate the component. Then the public interface of a component is ports. So here you can define some input and output ports. So those are the interface that the component gives to the outside world. You can define data types. We also support defining JSON schemas if you work with more complex data structures. And then finally, the important thing is you do a processing function. So this is basically, you give a function that's going to be called whenever your component receives input. And there you can determine if you have all the data, input data that you need to do your thing. And then finally you do something, and then you just send output, and that's it. But yeah, this is of course a little bit of boilerplate, and the good news is in a lot of situations you actually don't need to write the component. The nice thing about NoFlo components, or flow-based programming components in general, is that they don't know anything about the world outside of them. A component might have, of course, side effects. It might talk to some web service, write to a file, read a database, whatever. But they don't really know about how they are going to be used. They just provide these ports. And so generally when you write a NoFlo component or flow-based programming component, sorry it's bright, I know, I see some people blinking. It can be pretty much reused anywhere else where you need similar functionality. And that definitely helps with not having to write so much. So how do you then, so the second level of NoFlo is this graphs, the flows. And for that, first of all, we do support textual format. This is something that some people like to do. So here, I'm sorry, we are in a front-end conference, but I'm going to show a couple of Node.js things as well. So here, this is actually defining a web server that has some RESTful resource. So basically what you do there is you instantiate components like the server here or the parse there, and then you define connections between their ports. So the app port of the server goes to the app port of the parse. Yeah, so reactive is definitely a related programming concept, and like some of the flow-based programming community considers NoFlo kind of reactive flow-based programming. But yeah, the boilerplate stuff is something we definitely would like to reduce. We probably need to have some of it there because you need to do stream merges and more complex things like that, multiple inputs, multiple outputs. But, and for that, like just saying, okay, make this function a node is maybe not enough. But yeah, like a lot of those things are conceptually very similar, and I mean, maybe the introspective capabilities that we have are one of the edges there. So we can actually do this live changeability, visualization, all those things with this. Okay, anybody else? Next one.
I have a question. As far as I understand, this graph is represented in some other format, let's say so. The question is, when you have a team which works on the same, let's say, feature, and hence, like, do some separate stuff. In the end, most common case, you have a conflict. Is it a big pain to solve this? Because I had experience with system like this, and it was the biggest issue because merge conflicts.
Mm-hmm.
How it works. Thanks.
Yeah, so the graphs are stored as JSON files, and the format is reasonably simple, where we define connections between things, and that usually diffs reasonably cleanly. We also have a little helper tool called FPP-diff that you can use that to monitor, for instance, if you work with GitHub, you can use that to monitor your pull requests and visualize as a pull request comment what actually changed in a graph. So you don't have to like mentally parse the difference between two JSON files. You can actually see it right there in front of your eyes. So that helps with teamwork. We haven't worked with very big flow-based programming teams just because like ever since I started NoFlo, I've mostly worked in pretty small startups, but we had like 5-6 people working on the same NoFlo program, and that hasn't really been a problem. Yeah, of course, like merge conflicts happen, and then you need to resolve them. But I mean, that happens with anything that you version control, right? Okay. Anybody else?
Maybe you can show example of this JSON.
Sure. Let's see. What did I call it? I thought it would be nice to use the one I actually showed. Express demo. So, I mean, this one has a lot of metadata because I wanted to make that look reasonably nice, but you basically define the nodes you're going to use in the graph, and then you define the connections between them, and that's it. Just to give you an idea, here's the actual IDE. So in this case, the software is running. It's actually a NoFlo application we are pulling remotely. You can see the URL there. So we are in appflow.io here, and we're pulling the web application from noflo.js.org right here. And we can see the graph, and I can see the data that passes through live as it changes. So that's just to give you an idea how you can actually introspect NoFlo programs. So, any more questions? There's one on the back.
Hello. This looks really awesome for like especially mobile development. Do you know any example where you use that on React Native or something like that?
So, to my knowledge, this hasn't been used for React Native. I don't see a reason why it wouldn't work. I would actually be very interested to try. It's just that I haven't personally had any React Native projects, so yeah, it should work. If you try it, please let me know, and if there's any area that would need improvement, we would be happy to help. There's one example of native JavaScript development that we know people are doing, and that's if you're using Linux, one of the desktop environments is called GNOME, and that one actually is like the whole desktop is built in JavaScript, and that one you can modify this way. So you can do desktop Linux programming. You can do with this, like where all the widgets are native ones, but the logic is done in NoFlo. So that's probably pretty similar to React Native. Okay, one in the front. Maybe you just speak very loud.
Yeah, so it's basically the follow-up for previous. Is this concept suitable for UIs, like where you have tree structures?
Oh, okay.
Yeah. Is this concept also usable for UIs, like when you have a tree structure, like complex trees, or is it only for the business logic, you would say?
Well, I mean, this is a general purpose programming paradigm, so that means, of course, you can use it for anything. But I would say the typical sweet spot is more the business logic side of things. There's no particular reason why you couldn't define like DOM structures and stuff here, but generally that's not the way people use this. And for instance, in this UI, so this whole thing you see on the screen is actually a NoFlo application, and the way this one is done is all the business logic is in the NoFlo graph, and then the whole UI is actually a bunch of Polymer web components that receive data from the NoFlo graph and then send events back to the NoFlo graph. So we use very reduxive pattern, but just with not with React and not with Redux, instead with NoFlo and Polymer. Okay. Maybe one more if there's any. Okay, no hands. Very good. So in that case, dziękuję bardzo again.